it just gives me less time. So my plan is to finish on this Wednesday, give a quiz on Monday, do a review on Wednesday, and an exam on Friday.
Exam next Friday.
Yeah. Because there's no class this Friday. There's no class this Friday, right?
Right.
Or is there a class? No, there's no class. That's what I figured. All right. So let's start. So the last class we were discussing about capitalized cost of equipment, and we discussed that the capitalized cost basically means the amount of money. You can think of it as the amount of money that you have to put in a bank. So with that, with just the interest on that money, we can buy equipment in perpetuity as well as pay for the yearly maintenance cost forever. The idea is that this is your capitalized cost. And we said capitalized cost minus P, where P is the cost of the equipment, minus the yearly operating cost, the principal value of the annuity, which basically is 1 plus I to the power n, minus 1 divided by I, 1 plus I to the power n, times 1 plus I to the power n, must be equal to CC. Okay? So this is a capitalized cost. Think of this as the money we deposited. We immediately have to pay P to buy the equipment. The rest of the money is basically the money we'll be paying over the next n years to maintain the equipment, all brought at time 0. So that's the principal value of the annuity. The remaining money will grow, compound interest. After n years, it should give back capitalized cost. Does that make sense to everybody?
Mm-hmm.
So from this equation, you can solve for capitalized cost. So you can say CC will be, of course, we'll have two terms, P, and so the term for P is going to be P times 1 plus I to the power n divided by 1 minus sorry, 1 plus I to the power n minus.
He said the test is not going to be this Friday, but next Friday.
Right? Okay, plus YOC over I.
So why do you have CC on both sides of the equation?
Well, because we don't know CC, but the idea is that this is the rest of the money. We don't know CC, so we're just going to call it, define it as a variable CC. The idea is this was the original money deposited. This took care of buying it. This takes care of maintaining it. The difference will grow with the compound interest, and after n number of years, it better give us CC back so we can repeat the cycle, right? So that gives us an equation for CC that we can solve, and that's what we get. Right? So I take the CC term on the other side. So P goes to the other side with the plus. So P 1 plus I to the power n, CC comes here. So you get 1 plus I to the power n minus 1 for Y and C. This cancels this cancels that, so left with YOC over I. Okay? Make sense? No? Yeah.
Can you say again, like, after so many years, this is equal to capital cost and you get back that amount?
So this is CC, right? We pay a certain amount. We pay this much amount is P. And then we set away some amount of money to run the equipment. This is the rest of the money. It grows compound interest. After n, it has to go back to CC. This P is straightforward, right?
Yeah.
This is the annuity. This is the principal value of the annuity. So you have to, in reality, you have to pay YOC each year, right? For n years. All we're doing is we are bringing all that back to time 0. So that's just the principal value. Right? Make sense? So that's just the principal value of the annuity payment for the next 10 years. So this should be parentheses here. Okay? Yeah? Okay, all right. So can I move on or yeah?
If you're recovering CC at the end of it, why did you draw the line all the way down?
All the way down here?
Yeah.
No, I mean again, basically it will stop here. If you okay, if you want to do it like this. You like this more? Fine. Okay, so that's the remaining. It grows again. It comes down by again 2 parts, and keeps doing this in cyclic way.
And it does it after the same end, correct?
It has to, yeah. Because everything, each cycle is going to be exactly identical. Okay. All right. So now, so this is one way of thinking about it. This is one way of comparing 2 different options for equipment. So let's just do an example. I'm going to leave this thing. Okay, so let's do an example where we have to buy a pump and we have options, 2 options. Or let's say 1, 2, and 3 options. So the option 1, the pump A, let's say costs. So let's say we have the cost, YOC, and the number of years. Okay? So let's say pump 1 costs 10,000 to buy, this costs 15,000 to buy, this costs 20,000 to buy. Let's say the number of years, this will run for 3, this will run for 5, this will run for 7. And let's say the yearly cost of operation is 2,000, 2,500, and let's say 2,500. The yearly cost of manufacture, I mean, yearly operation cost will not differ a whole lot because the pumps are only doing the same job, right? So, but you can see the main difference is that the cost of buying different pumps is different, and so is the yearly life. So now the question is, given this data, which pump will you buy? Okay? So to do that, all we do is figure out the capitalized cost. So let's figure out the capitalized cost for these options. So what's the capitalized cost for 1? And let's take I is always 10%. Okay? So can somebody calculate for me?
What are the yearly costs?
2,000, 2,500, 2,500.
About 60,000.
Okay, 60,000. For option 1, option 2. Okay, 5,000. Okay. 3. Yeah. Sorry?
Why do you pay the,
To buy the equipment.
to buy it, but do you pay it again after, do you pay it after every,
And years, because you buy it again after 3 years. And it's the equipment life.
oh, okay.
After 3 years, you have to buy this again. After 5 years, you have to buy this again. If you choose this, you have to buy every 7 years.
For option 3, it's 66.
Okay, so you can see it's pretty obvious. Which one will you buy? Sorry?
One.
1, right? Because you want the lowest possible capitalized cost. Yeah.
We only get it for 3 years though. Once you run the pump, once you run it.
But that's the whole point. That this $60,000, if you put in the bank, you would have paid for this equipment forever, right? If you buy this equipment, now in reality, of course, you never put money in the bank, right? Just for equipment. Otherwise, you'll have millions of accounts. But this is a way of analyzing. Another way of thinking of it, this is the capitalized cost is simply the principal value of all the investments incurred on this equipment for infinite years, till perpetuity. Right? Does it make sense? So yes, you have to pay for this every 3 years, but this 60,000 is everything brought to time 0. Right? All the purchase costs, all the operating costs forever. Now, of course, if somebody would have asked, which equipment will you buy if you know that you are going to dismantle the plant after 10 years and you get no salvage? Then your question could be different. Then your answer could be different, sorry, right? So how would you answer that question if somebody asks, okay, 10 years and that's it. After 10 years, we're done. Yeah?
I'm guessing number 2 because then that's like the end of its life.
Right, very good. So your gut feeling tells you 2, but you can clearly see, but how would you actually do this quantitatively? Most likely 3 will be a poor choice because at 10 years, if you get no salvage, you're wasting 4 years of life and it's an expensive equipment. This is 3, 3, 3, 1. So the choice is between 1 and 2, right? Yeah?
Could you combine 1, 2, 3 and a 1?
What?
Could you do 1 pump 3 and 1 pump 1 and that'll give you 10 years?
Yeah, but you can also just do 5 and 5.